Our universe is vast and mysterious, stretching farther than our eyes can see. And for thousands of years, humans have gazed up at the night sky, filled with wonder and curiosity. Each twinkling star, every glowing nebula, has inspired questions about where we come from and what lies beyond. The James Webb Space Telescope is our newest and most powerful tool for exploring these cosmic mysteries. It's not just another telescope, it's a time machine, allowing us to look back billions of years to the earliest moments of the universe. With its advanced technology, Webb is designed to reveal secrets that have remained hidden until now. Launched in 2021 after decades of planning and international collaboration, it traveled 1 million miles from Earth to reach its special spot in space, far from our planet's interference. Its giant golden mirror, made up of 18 hexagonal segments, captures the faintest glimmers of light from the distant past, letting us see galaxies as they were billions of years ago. This mirror is so sensitive, it can detect the heat of a bumblebee on the moon from Earth. Webb can see in infrared light, which means it can peer through thick clouds of cosmic dust to study the birth of stars and planets, places that were invisible to previous telescopes. On September 1st, 2025, scientists announced a discovery made by Webb that challenges everything we thought we knew about our universe. This breakthrough has sparked excitement and debate among astronomers and physicists worldwide. Webb wasn't just looking at the distant past, it also keeps a close watch on our cosmic neighborhood, monitoring asteroids, comets, and other objects that travel through our solar system. It helps us understand the dynamic environment around our own planet, and sometimes it spots things we never expected to find. One such surprise was a mysterious visitor from another star system, a traveler with a story we're only beginning to unravel. This discovery pushes the limits of what we thought possible, opening up new questions about how objects move between the stars. It reminds us that the universe is full of surprises waiting to be discovered. The James Webb Space Telescope is a revolutionary tool for a revolutionary time, giving us a new perspective on the cosmos. With every new image and discovery, it opens doors to understanding the universe in ways we never imagined possible. Meet 3I/Atlas, an interstellar traveler from another star system. It's the third confirmed interstellar object, first spotted by the Atlas telescope in Hawaii. These objects are like messages in a bottle, offering clues about their origins. 3I/Atlas seemed like a comet, expected to release a tail of gas and dust. The James Webb Space Telescope was tasked with getting a detailed look. Webb would measure its size, shape and composition, analyzing its gas and dust. Scientists hoped for surprises, but no one expected what they found. The data challenged everything we thought we knew. The James Webb Space Telescope, humanity's most advanced eye in the cosmos, was trained on a mysterious interstellar visitor, 3I/Atlas. As the telescope collected precious photons from this distant object, scientists around the world watched with anticipation, eager to unlock its secrets and learn more about the universe beyond our solar system. At first, everything seemed routine. The data streamed in as expected, and the object's path appeared to follow the laws of physics. But then, something strange happened. Something no one could have predicted. The object began to drift off its predicted course, its movement becoming erratic. It was moving faster than any of the models had anticipated, and the change was happening in real time, right before the scientists' eyes. The telescope's guidance system worked overtime, making constant, minute corrections to keep the object in view. Every adjustment was logged, but the object's acceleration continued to increase. The drift was not only consistent, but the object was accelerating in a way that defied all known explanations. There was no visible tail, no outgassing, and no sign of a propulsion system, nothing that could account for such a rapid change in velocity. Scientists searched for any clue, a faint gas jet, a dust trail, or even a hidden force. But the space around 3I/Atlas was empty and silent. The numbers on the screens didn't add up. Calculations were checked and rechecked, but the data was clear. Disbelief and confusion filled the control room as the velocity readings flashed an error message. Then a final calculation stunned everyone. 3I/Atlas was moving faster than the speed of light, a result that should have been impossible according to everything we know about physics. The result seemed not just unlikely, but utterly impossible. Yet the instruments confirmed it again and again. The room fell into a heavy silence as the implications began to sink in. Scientists stared at the data, grappling with the possibility that they were witnessing something that could rewrite the laws of the universe. This observation defied every principle of physics we thought we understood. It was a moment that challenged not just our technology, but the very foundation of our understanding of the cosmos. In that instant, the universe seemed to whisper that there are still mysteries waiting to be discovered, moments that remind us how much we have yet to learn. The idea of moving faster than light breaks a fundamental rule. Einstein's theory of relativity sets the speed of light as the ultimate limit. Seeing an object break this law is like seeing a fish fly to the moon. Scientists consider it might be an illusion or a trick of perspective. Perhaps a gravitational effect distorts space-time, creating an illusion. Another idea is that 3I/Atlas is something exotic like tachyons. Could it be an alien probe with advanced technology? The data from Webb forces us to ask extraordinary questions. This discovery challenges our understanding of the universe. This isn't the first puzzling interstellar visitor to intrigue astronomers. In 2017, Oumuamua, a cigar-shaped object, accelerated mysteriously, defying easy explanation. In 2019, 2I/Borisov behaved like a familiar comet, but came from another star. These objects showed the range of possibilities drifting through interstellar space. Now, 3I/Atlas shatters the speed limit of the cosmos, racing past all expectations. Each discovery adds a new piece to the cosmic puzzle we're trying to solve. Oumuamua was strange, Borisov was familiar, and 3I/Atlas is truly unprecedented. These visitors remind us that our solar system isn't isolated or alone in the universe. They offer a stream of new mysteries and questions for us to solve. 3I/Atlas feels like a piece from a completely different puzzle box, challenging our understanding. The James Webb Space Telescope is an engineering marvel of our time. Its giant mirror, coated in real gold, reflects faint infrared light from the universe. Webb must be kept incredibly cold to avoid its own heat, interfering with observations. Located 1,000,000 miles from Earth, it has a massive, layered sunshield. The telescope's sensitive instruments split light into different wavelengths for analysis. This spectroscopy reveals the composition and nature of distant cosmic objects. Webb's precision made the shocking discovery of 3I/Atlas possible for astronomers. It measures motion with incredible, almost unimaginable accuracy. Understanding Webb's unique capabilities helps us truly grasp this discovery. The telescope's design allows us to see the previously unseen universe. If proven true, this discovery forces us to rethink physics as we know it. It's not just a small adjustment, it's a seismic shift that could ripple through every branch of science, from the tiniest particles to the largest structures in the cosmos. The very foundation of our understanding is suddenly up for debate. The speed of light as a constant is a pillar of modern science. It's the ultimate speed limit, woven into the equations that describe everything from gravity to electromagnetism. For over a century, it's been the rule that nothing can break. An object travelling faster than light challenges cause and effect, threatening to unravel the very logic of time itself. If something can outpace light, could it also move backward in time or send information into the past? The consequences are staggering. It opens possibilities once confined to science fiction, like warp drives, shortcuts through space, or even time travel. Suddenly, ideas that once belonged to imagination might become real scientific pursuits. The scientific community will carefully examine this result, testing and retesting every detail. Extraordinary claims demand extraordinary evidence, and skepticism is a vital part of the process. If it's an illusion, it could lead to new theories about gravity or reveal hidden aspects of the universe we've never considered. Even a mistake can spark new ideas and discoveries. If it's alien technology, it answers the question of extraterrestrial life, a question humanity has asked for generations. It would mean we are not alone, and that other civilizations have mastered physics beyond our wildest dreams. This discovery could redefine our place in the universe, forcing us to see ourselves as just one part of a much larger, more mysterious cosmic story. Science is a slow process, and this anomaly starts a new conversation, one that will inspire debate, curiosity, and perhaps a new era of exploration. The implications are profound, no matter the final explanation. Whether it's a breakthrough or a puzzle, it reminds us that the universe is still full of surprises, waiting to be uncovered. The universe surprises us, showing things that shouldn't exist. 3I/Atlas reminds us we're explorers on a cosmic shore. Discoveries like this invite us to adventure and expand our knowledge. The search for answers will push technology and inspire new generations. The journey to understand 3I/Atlas will teach us much. This is a wonderful time to be alive with tools like the James Webb Space Telescope. Curiosity drives discovery, and we all share in this quest. Keep looking up and asking questions. The universe is telling its story, and we're learning to listen. Our journey to understand the cosmos has only just begun.